Let's go ahead and get started with lesson 2. We got carbon compounds. So remember, we're talking about things in life. So now we're looking at specifically carbon compounds, and there's so many of them. In fact, if this section interests you, you can spend about 8 years in college learning about carbon compounds and then spend the rest of your life still learning about carbon compounds, but probably getting paid a lot of money. Alright, so first, we've learned this word before, organic compounds, one of a large group of compounds that always contain carbon. We have definitely had that as a vocab word before. You guys should know that by now. If it's an organic compound, it always contains a carbon. Not necessarily the other way around, okay? But an organic compound is one of a large group of compounds that always contain carbon. Most of the compounds in living cells are organic compounds, but not all carbon compounds are organic compounds. Okay, that's what I'm saying. It doesn't always work the other way around. Diamond is not an organic compound, but that's nothing but carbon. Does that make sense? But many of the things that you're made up of has carbon in it. Therefore, all of those are organic compounds because they contain carbon, and they're in a living thing. Now, carbon's really cool because it can form 4 covalent bonds. And what that allows it to do is make short chains, or long chains, or branch chains, or rings, or any other shape you can think of. Some crazy looking pyramid. Let's see if I can find one real quick. These crazy, like, soccer ball looking, these are molecules. These are atoms that carbon can make because of the way carbon is able to do that kind of stuff. So carbon's really versatile. It can do all sorts of things. But that's when we're talking about single bonds. It can actually also make double and triple bonds, which, remember, that means in a single bond there's 1 pair of electrons being shared. In a double bond there's 2 pairs, and in a triple bond there's 3 pairs of electrons being shared. So it can do all of them: single bonds, double bonds, and triple bonds. Here's a couple examples of carbon compounds. On the top we got methane, which you've heard come from farts, which is true. Per year, cattle will release about 120 kilograms of methane into the air, whereas you will probably release 0.12 kilograms of methane per year. Some of you, that might be higher if you're a gassy person, but on average people give 0.12 kilograms of carbon to the atmosphere every year. Down here we have something called ethylene, which is the reason why apples will go bad. This compound kind of triggers another chemical reaction that makes fruit brown and stuff, and this is what it looks like. Carbons attached to some hydrogens. And then over here we have an ethene torch, or you might have heard it called an acetylene torch. Different word, but the same meaning. And they're cutting this piece of metal down, so if you've ever used one of those, I never have, but I know some of you probably have, or at least seen it used before. That is also technically a carbon compound. Everybody usually enjoys this one. This is vanillin. This is what the flavor of vanilla looks like. So anytime you've eaten something that's made with actual vanilla, this compound is in it. And each turn right here, like this, each point, there's a carbon atom there. They just don't show that because it would take up so much space. So there's a carbon here, 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 all sorts of carbon everywhere. You can see in this picture all the gray dots are carbon. But that's what vanilla smells like and tastes like. That's what it looks like to us. Or not to us, but that's what it looks like if you zoomed in all the way. So you'll notice that in this example, and in this, oh, this isn't true. Ruin my example. You notice in this example, not this one, that there's only carbon and hydrogen. If there's only carbon and hydrogen in this compound, it's called a hydrocarbon. The hydrocarbon. Pretty straightforward. Now, because carbon can form bonds with other atoms, it can form long chains. So it can just keep combining carbons and hydrogens, super really long chains, like ridiculously long chains. And if all of them are only single bonds, so a bunch of everybody sharing one pair of electron, only single bonds, it's called saturated. And if there's ever a double or a triple bond, then we call it an unsaturated hydrocarbon. You guys might have heard of saturated and unsaturated fats. This is exactly where it's coming from. They mean the same thing here because they're the same word. Unsaturated fats are hydrocarbons that have at least one double or triple bond between them. So here are 4 really common hydrocarbon compounds. In fact, they're the 4 smallest ones you can have. We got methane, once again, coming out of your farts. CH4, so there's 1 carbon, 4 hydrogens. If we add another little carbon in there and surround it with hydrogen, then we get something called ethane. And if we add another carbon there, we get something called propane, like the stuff some of you might use to barbecue. And if you throw 1 more carbon there, you get butane, which, if you remember that torch I used in class, it runs off of butane. It's a butane torch. Here's what it looks like, molecular formula. Imagine trying to figure this out. Basically, we just keep adding a CH2 in the middle. You see that? CH2, 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 CH2. The CH3s on the outside always stay the same. The prefix means something. So, like, you guys know what a pentagon is. It has 5 sides. Well, pentane has 5 carbons. Octane has 8 carbons, just like an octagon has 8 sides. So the prefix tells you how many there are, essentially. Here, we see that the root words are really important to how we're naming these compounds. And pretty much all the compounds except for the first 4 are based off of Greek numbers. That's why you guys already know. If I said octane, you guys can guess that has 8 because octagon has 8. We keep using the word ANE, right? That means that there is only single bonds. If we said something instead of propane, if we said propene, that means that there's at least 1 double bond. And if there's a triple bond, then we have YNE instead. So the suffix means something pretty important, whether it's only single bonds or double bonds or triple bonds. And then we can even arrange hydrocarbons in circles. And if we do that, then we throw the word cyclo in front of it. So cyclopentane. Cyclo, because it's in a circle. Pent, because there's 5. And ane, because there's only single bonds between here. So cyclopentane. A 5-carbon atom joined by single bonds in a ring. Going back to the idea of saturated and unsaturated things, you guys might have heard certain fats are more healthy for you. Unsaturated fats usually are healthier for you. That's what we get from vegetables. They're usually liquid at room temperature. And that's because, remember, unsaturated has a double or a triple bond, and that kind of bends the fat to where it can't stack very easily. Because the ones that can stack very easily, like the stuff we get from meat and butter and stuff like that, because it stacks, it can clog your arteries. And that's not to say you can't eat cheese or can't eat meat or anything like that, but you shouldn't eat too much of this. And that's why they say you can almost always eat more vegetables because it almost doesn't matter. This is considered like the good kind of fat, but you can still eat this, don't worry. Here we see more examples of hydrocarbons. The only difference between plastic, motor oil, diesel, and gasoline is how big the chain is. Plastic just keeps going, you see that. Motor oil has more carbon than diesel, but it's still the same stuff. And gasoline has the least amount, but it's still only carbon and hydrogen. We went over that. Remember, cyclo means it's a circle, pent means there's 5, and ane means it's only single bonds. So a circular compound with 5 carbons that only has single bonds. So everything we've been talking about is just for straight hydrocarbons, okay? But we can sometimes replace one of those hydrogens with something else. If we did that, we get something called a substituted hydrocarbon. The things that are doing the substitution are called functional groups. They replace a hydrogen atom with inorganic compounds. This functional group changes the properties of the organic compound from the original hydrocarbon on which it is based. So it's no longer the same thing. All we did was replace one of the hydrogens with something else, and it will no longer act the same way. Here we see three examples that we're going to go over: the hydroxyls, carboxyl group, and the amino group. So here, instead of this being an H, we now have an OH. Instead of this being an H, we have a C with two O's attached to it and an H over there. This is a double bond, although it's really hard to tell in this fuzzy picture. And instead of an H here, we have a nitrogen attached with two hydrogens. So they're no longer only hydrocarbons. They have these substituted functional groups in there. So if you ever replace a hydrogen with a hydroxyl functional group, you get something called an alcohol. Yes, some of them are the kind of alcohol you're thinking of. A hydroxyl group consists of one oxygen atom covalently bonded with one hydrogen atom. So right here, one oxygen with one hydrogen. Regular hydrocarbons do not dissolve in water, but once we do this, once we put a hydroxyl in there, now we can dissolve it in water. And that's why you can have a 70% isopropyl alcohol solution, because you can dissolve this in water now that it has this little chunk. But propane gas does not dissolve in water. All we did was switch this H with an OH, and now we can dissolve it in water, and now it does something completely different than this stuff over here. But notice that's the only difference right there. Next up is one of these carboxyl groups. Consists of carbon, two oxygen, and one hydrogen. And as I said, there was a double bond there, but it was kind of hard to see with the fuzzy picture. These are called carboxylic acids. Try to say that out loud. Carboxylic acids. Aspirin is one of these examples of a carboxylic acid, as well as lactic acid, the stuff that builds up in your muscles when you work out too much and then you get sore. Both of those are carboxylic acids. Here we see this should just be an H like over here, but since instead it's a carboxylic group, we have now changed this entire thing into aspirin, the stuff that you take if you get like a headache or whatever. Lastly is the amino group. This is when we switch out a hydrogen with a nitrogen attached to two hydrogen atoms. If we do these things are called amines. Okay, amino groups make amines. So all we're doing is replacing one of the hydrogen with a nitrogen and two more hydrogens. You guys might have heard of histamine, maybe in anti-allergy medications like antihistamines. That compound, antihistamines, block this compound, which is a histamine, from doing what it wants to do. I'm going to post this video, and once again, we're not going to watch it here, but go ahead and pause this video, open this link, and then watch the video before continuing. Substituted hydrocarbons with both an amino group and a carboxylic groups are called amino acids. Now, these things are incredibly important to you because those build proteins. So, amino acids and amino groups and carboxylic groups combined make an amino acid. Amino acids make proteins. You are made of proteins. So all of this is incredibly important because it's telling you how to make you, essentially. You're made up of proteins, proteins are made up of amino acids are made up of this stuff. So it's all just building on each other. In your body, there's about 20 common amino acids. Your body can make 11 of them. So then the question is, well, where do the other 9 come from that you need to survive? Well, you got to get them from foods you eat. That's why it's important to eat food. I mean, that's one of the reasons why it's important to eat food, right? So here we see an amino group, the N and the H's. and a carboxylic group with a COOH, and this double bond that now you can actually see. Here's a big graph. You don't need to know this, like in and out. I just wanted to show you the ones that are dotted lines are the ones that you need to eat in order to like live. But the ones with the solid lines, your body can already make. If any of you have gum or diet soda nearby, or sugar-free anything, you can probably look on the back, and it'll probably say something about this one right here, phenylalanine. That's because for some people that's really dangerous. But for most of you it'll be fine. But some of you, that probably not any of you, that's dangerous. And section E kind of doesn't really fit the rest of it, but all it says is we can use models, like 3D models, to picture what these molecules might look like. And if we do that, sometimes it helps us explain some of the properties of compounds. So here we see methane is like a triangle, ethylene is a flat rectangle, ethyne in this case is a straight line. So this kind of leads you into, like I said, you could be studying this stuff for the rest of your life, making a lot of money, because this just brings us into a crazy amount of science that we don't have time to go over. But if you're interested, then definitely keep that in mind as you continue your schooling. A tetrahedral shape is this pyramid right here. Tetrahedral. It's a 3D pyramid almost. And that's it for lesson 2.